let's go for example, the number 5. Every partition gives us some way of looking at the whole number. But we go here in organic mathematics, we go one step, a little step further than the partition, and this can do the whole change, analyze every partition. We define for every given partition, a given number n, the number of distinction it adds. This is the, yes. You see the number 5 have these 7 partitions. For example, the partition 4 plus 1 give us 9 different distinctions. 3 plus 2 give us 6. I will explain to you later how we calculate. Then we summarize all the distinctions that each partition gives, and we go to the number 24. So the number 5 have 24 distinctions. Until now, we saw that 1 is 1 distinction, 2 is 2 distinction. This is the beginning, the origin of organic mathematics when we bring uncertainty into the structure of numbers. 3 have 3, we saw it, certainty, uncertainty, and something inside. Then case 4 give you 9, I didn't explain it yet, the 5 and 24, and this we call the organic sequences. Let's study in detail the case of 4. For that we are bringing a notion of 3. We present number by 3. Let's see how we do it. We have 5 partitions, and we will present. But first of all, I will introduce you the notion of the 3. When we have 1, then you remember when we have 1 bit, it's very simple. There's complete certainty. The point identity is clearly known. When we have 2, in the first case, the identity of the points is in a superposition, which means that these bits can be a superposition of the A and B, and this can be a superposition of A and B. This is the case, and there's a case where we know exactly the identity. So this is the identity of the point is not a superposition, so we summarize it by the 2 possibilities. 1, uncertainty and certainty. This is the notion of the 3 that we present organic number. The notion, the 9 present that we are talking about a superposition of the 2 possibilities. The case of 3, we present it by, this is the case of complete uncertainty, partly certainty, partly uncertainty, and the case where we know the identity. So this is the notion that we present, the 3 notions that we present for organic number. Now let's go to the number 4. First of all, we have the partition 1 plus 1 plus 1 plus 1, like this, 1 plus 1 plus 1, and it means that each element have all the possibility, A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. So this is very simple, it's repeat all this. Now, the next partition is become 2 plus 1 plus 1. Each one have all the 4 possibilities. But the 2, it's the word of 2 inside the word of 4. So in fact, we have 2 possibilities for the 2. It's certainty and uncertainty, and we present it by this way. So in fact, we have two distinctions for this partition. The case 2 plus 2, we have in fact, theoretically, we have 4 possibilities, because each one of them have 2 possibilities, so we can do the multiplication. But we reduce one case. Why? Because this is the case uncertainty, uncertainty, and certainty, certainty for the 2. But look that these 2 distinctions have the same meaning. It's certainty, uncertainty, and uncertainty, certainty. But since we are talking about parallel observation, like in the partition, there's no meaning to the order, we reduce one of them. So we go to 3 distinctions for this partition. The partition 3 plus 1 is the first place when we know exactly the identity of the bits. One of the bits, this is the traditional mathematics in piano system. Every number is 1 plus the number that comes before it. So this, we take from it the case that for the first time we know the identity of one of the bits. It tells us that this is D. And so we have a simple recursion. We have a recursion of the 3, so we have 3 possibilities. Okay, you can see the recursion. This is known, and here we have the word of 3 that I presented to you before. So now we can come to the final conclusion. We summarize each partition, what is the number of distinction that it gives, and it comes to the number 9. And the line that is drawn here, it means that in the parallel observation, we are talking not about them not separate, but together. It's a superposition. The organic number 4 have 9 distinctions, which are in a superposition one to another. Here is the algorithm that we developed to calculate the number of distinctions for each number. You can see that in the beginning we're talking about partition. This formula GAB is a way to summarize what I described you in detail. And finally we summarize all the distinctions that each partition comes, and we get the final result, which is the number of distinction to each number. And here's the structure of the tree. Now the number 5 have 24 distinction 24. Now I come to the main point, the question. Okay, I define a distinction, I define an algorithm. What is the meaning of all this? Now, we are talking about uncertainty and redundancy. What are we trying to do here is to bring concept from quantum world, which means redundancy and uncertainty, into mathematics. So what are we trying to do here is trying to do what happened to physics 100 years ago, when there was a revolution in relativity and in a quantum theory, and we try to take this idea and to bring and to do the change in mathematics. And in mathematics, the most fundamental concept, which is the concept of number. So, here, this slide represents the essence of what I'm presenting to you. If we have a prism, yes, you know the prism, we have white color and different color. So, the matrix of uncertainty and redundancy present the white color. We don't know the identity. But when it goes to the prism, then we know exactly the identity of the element. So what I'm trying to talk to you, to tell you today, is very simple. Quantum theory said we are not looking at the phenomena by itself. We are the observer. I'm telling you the same about number. I'm telling you, when we talk about the ordinal, when we talk about the amount of bits, it's simple. When we talk about the partition, it's simple. It's something outside. We know what is the partition outside. But when I'm talking to you about the distinction, I'm talking to you how the number appears in myself, in my cognition. So, like the revolution that happened in physics when we give up on the Newton laws, when Newton said we are observing the world from the outside like an aquarium, they said no, we are inside the world. So I put to demonstrate you the bits inside the aquarium of the world. What we say that mathematics, we are the mathematicians, and mathematics is part of the world, and we want to do the change into mathematics. Here are the final, I have 2 minutes. Here's an example. A famous mathematician, Ramanujan, who discovered 4,000 formula, and he was unique in his way of thinking. We think that our theory can explain how Ramanujan get to his idea. Organic mathematics look at a line point as different atoms that are not divided one from another. In organic mathematics, a line is not a collection of infinitely many points. There's 2 atoms, and everything is the bridge between them. We are working with young children. They are not influenced yet with the traditional education. We see the power of the dialogue with young children at 2 abstract observations that is associated and able to define things mathematically, where distinction is the first order property. We suggest a new approach to the 6th problem of Hilbert. in his family lecture, because Hilbert was talking about, it was in 1900, it was 5 years before the miracle year, and he's talking about probability and mechanics. In mechanics, Einstein did a revolution in mechanics. What we are talking about, probability. We are talking about, like the lecture before, new thinking about probability. We present distinction as the first order property in mathematics, uncertainty.
Okay, I think we are very grateful for this very interesting talk. So let us thank the speaker.